Hello people, welcome back to the corgi64 project. We're in our third episode, and today we're going to write our first opcodes for our simulated CPU. So the first thing that we're going to do here is we're actually going to delete this hello.cpp file. We don't need it anymore, so we're going to just delete it. The second thing that we're going to do is if we're going to start, writing these opcodes, we need to look at our CPU design. And what we're going to do is, instead of starting off with moving things from registers to registers, let's start off with something very simple: addition. So we're going to do the various arithmetic operations, or at least the simple arithmetic operations: add, subtract, multiply, divide, and modulus. So what we're going to do for that is we're actually going to go over here, and we're going to start creating our functions. Now, keep in mind that we're also going to want to do some testing. So we'll end up writing tests actually really soon. But first, what we're going to do is we're going to do static void add CPU, and we're going to give it a pointer to our CPU. And what we're going to do is the CA register is going to equal A plus B. So what we're going to do with our CPU is, for our arithmetic operations, which we already wrote about above here, all our bitwise and arithmetic operations store the result in register A, and all the operations will be between registers A and B. So that means that we will always know that A and B will be our two registers, and we're always going to store our result in A, so that makes it very easy. The other thing that we'll want to do eventually, we won't do it right now, but we're going to have to keep in mind that we have this status register. Maybe we'll name it to F, like we have here for our flags. In fact, we may just call it flags right now. And what we're going to have to do is, every time we do one of our operations, we should probably set the proper flag bits to make sure that they are set properly. Because later on we're going to implement our jump instructions, and these different jump instructions are dependent upon our flags being set. So we'll actually make a note for ourselves there. So note fill, remember to set flags after doing arithmetic. Okay, so that's something that we'll set up later on. What we're going to do, actually, we'll take this and move it down here, and let's test out to see if our this operation will actually work. So what we're going to do is we're going to go down to our main function over here. We're going to create a CPU, a pointer to a CPU, which we're going to do a malloc of the size of CPU. We're not going to set the, we're actually going to reset the CPU. And we're not going to set the memory right now, because we don't need it. All we have are registers, and we're doing things with our registers. So the first thing that we're going to try to do is we're going to add, and we're going to set our registers to certain values. So register A will be 3, register B will be 4. We'll have, let's do an add on our CPU, and then we need to do an assert to make sure that our A register equals 7, because that should be the addition of 3 and 4. We're also going to say 3 and add 3 and 4 is, let's do a long double, and we'll have to say that this is an int64t over A. And the reason we have to do this casting here is because up here we're doing a using, In normal C, we would perhaps do a define or something like that, which would just be a text replacement. This is actually creating a new type called I64. So if we just try to print this out, it's not going to see it as an int64t. It's actually going to see it as an I64, which is completely different. So what we're going to need to do is we're going to need to cast that. The other thing that we're going to need to do is if we're going to use assert, then we need to add the assert library. So we'll include C assert here, and that should be good enough to set up our CPU, set up our registers, and do an add function. So let's see how that works over here. So let's do a dir. We're in our library for our CPU, or our top level directory. We're going to do a build.bat, and it says, oh, it looks like we're missing a semicolon on line 17. So let's see. Yes. Wait. No, are we? So this shouldn't be state, should be static. Let's do a build. Let's see. So is there somewhere else where we've got status, or did we save? Build.bat. Let's see what we've got. Okay, status is not a member of CPU. Line 47. Oh yeah, we changed this to flags. Of course. So we can do the build, and now we have our function, and if we run it, we get 3 and 4 is 17. In fact, what we'll do is instead of saying add, we'll just say 3 plus 4. So now we've got our first opcode. So now that we've got that running and tested pretty well, what we're going to do is we're going to build a few more of these things. So let's copy our code for addition, and we're going to have subtract, multiply, divide, and modulus. So this will be add, subtract, multiply, divide, and modulus. Now this is always very dangerous because if you copy code, there's always a chance that you will forget something, which is why we write tests. So that should be add, subtract, multiply, and divide, and modulus. So let's go ahead and test these things here. So let's copy these lines, and what we'll do is we'll do subtract, multiply, divide, and modulus. Now let's do 3. Let's see, subtract. Now remember, this is all with the same. We haven't changed our registers at all, so we've got 3 and 4. If we add, A will now have 7 inside of it. So if we do a subtraction, we'll now have 7 minus 4, which should be 3. And if we do a multiplication, we'll actually be multiplying 3 by 4, which should be 12. If we do a division, we'll have a 12 divided by 4, which should be 3. And then if we do a modulus should be 3 mod 4 will be 3. And let's change the name of all these. So we've got subtraction, multiplication, division, and mod. So I think we've covered everything here. Let's see if we can build. So it looks like we built. What happens if we run? Okay, it looks like we printed stuff out, but we forgot to add a new line. So let's add a new line for each one of these and make them a little bit easier to read. We'll build again and run, and now we've got 3 plus 4 is 7, 7 minus 4 is 3, 3 times 4 is 12, 12 divided by 4 is 3, and 3, oh, we need to change this, 3 mod. That's right, we need to have a, we need to escape Hopefully that doesn't escape. Let's see. Let's build and run and 3, so that doesn't do that. So let's just say 3 mod 4. That makes it very easy. So we'll do a build and run. 3 mod 4 is 3. So now that we've got these, let's see, how many of these functions do we got? Add, subtract, multiply, divide, mod. So we've got 5 opcodes. They seem to be working pretty well. So what we're going to do is we're actually going to write these tests for them. There's no reason to have 57 tests in our main function over here. That's what testing is for. So let's actually move our tests over here. We'll have to include assert. Oh, the other thing that we'll have to do is we'll want to actually take our code for our CPU and actually move it into a header file so that way we can include it in our test file. So let's go ahead and do that. Let's go to our source directory and create cpu.h, and let's go ahead and copy all the code for that has to deal with the CPU, and move it over cpu.h. And then I think the only header file that we'll need for our CPU, it looks like the only thing that we'll need here is the standard int. So let's take the cstandard int, move it over to the cpu.h, and now let's include cpu.h, and we'll build. Looks like it worked, and if we run it we still get the same answer, which is great. So now we've got a much smaller main function, and we've got a cpu.h file which we can now include in our tests. So we'll include cpu.h, and here in our main function what we'll do is we'll do the same sort of thing that we were doing over here in main.cpp. We will create a CPU, and then what we'll do is we will we actually need to write test functions for all these things. So we'll have a void test add, we'll give it a pointer to our CPU, and then we will set our registers what we want them to be. So this one will be 3 and this one will be 4. Then we can actually call add on our CPU and then perform an assert that our A register equals 7, and we'll just copy our print function over here since we wrote that correctly. And we probably won't have this print function later on, but just for our own purposes we'll have it for right now so we can see what's going on. At the end of this we'll want to say all tests passed, and then what we're going to do is actually let's just try out this add function first. So we'll do test add, give it our CPU, and the other thing that we'll need to do is we don't want to write out a long we want to have a build .bat file for our tests, so that way we don't have to write complicated commands every single time, or it's not very complicated, it's just annoying. So we're going to copy stuff from build.bat and create a test or build tests.bat. So what we're going to do is we're going to go to build.bat and we'll copy it and we'll paste the same stuff in here, except instead of main we'll have tests, and that should allow us to build our tests.cpp file. Let's go ahead and try that build. So build tests. Let's see, it looks like print is not found. We need to have a printf. So there we go, and let's see if we can we have a test.exe, and we have our addition, so that's very good. Let's go back here and create subtraction, multiplication, division, and modulus, and we'll just update all of these functions so that way they do what we want them to do. So let's do subtraction, and we'll actually set these so as if it was the same as our test that we had over here in main. So let's go ahead, and 3 plus 4 was 7, so this one we'll assert 3 here, because after we subtract should be 7 minus 4. This one will be 3 and 4, and we'll multiply them together. And we'll assert that this will be 12. And this one will do a divide, and we'll divide 12 by 4. And we will assert that that will be 3. And then finally we will have a modulus of 3 by 4, and we will assert that that should be 3 as well. And that should be our tests. So let's go ahead and do test subtract copy that, multiply, divide, and modulus. Multiply, divide, and mod. So let's see if we can build our tests again. Looks like they built, and they actually all ran, so that's fantastic. So now we can go back here. We have our tests, at least a start to our tests. We can go back over to our main function. We don't need this anymore. And what we'll do is we can actually let this go. Okay, so now we have our CPU in its own file. We have 5 different opcodes written. The next thing that we want to do is we actually want to add these opcodes to our opcode table. And this will allow us, because the way that our CPU is going to work is it will have memory attached to it, and our CPU, when it sets off running, it will start reading memory, and it will read our program and execute it. And the way that it executes it is it decodes the instructions, and then it says, okay, the instruction tells me to go to a certain opcode, and I will execute that opcode. So let's go ahead and look back at our CPU design and take a look at where add is going to be. And it looks like add is in hexadecimal 16. So we will start there, and they each go up by 1, so 17, 18, 19, 1A. So let's go ahead and add the opcodes that we created to our list here. So looks like, what would we say, 16 is where we're going to start. So let's go to our cpu.h. Let's go to 1, 6, and put add, subtract, multiply, divide, and modulus. And now we've added our opcodes to our opcode table. And that's in preparation for us being able to actually write programs. So next time what we'll do is we'll actually go and we'll actually create some opcodes for setting register values. And once we do that, we'll actually have enough opcodes available to actually read memory for us, and we'll be able to write some simple programs in our bytecode. So we'll actually be able to write binary programs, put them in memory, and run them. So that's it for now. Thanks for watching. Till next time.